This is Mrs. Appia with Lesson 23, using sample data to compare the means of two or more populations. Student outcomes for this lesson. Students use data from random samples to draw informal inferences about the difference in population means. Statistics is about making decisions concerning populations. In many settings, this involves deciding whether two population means are similar or different. More formal procedures are presented at the high school level and beyond. This lesson builds on the previous lesson to present an informal, inferential procedure. The bottom line is that if two sample means are separated by at least 2 MADs, then it is reasonable to conclude that there is a difference between the two corresponding population means. Recall that in Lesson 21, a difference between two sample means was called meaningful if it is greater than what would have been expected just due to sampling variability. This is an indication that the corresponding population means are not equal. In the previous lesson, students calculated how many MADs separated two sample means. This lesson extends that procedure to informal inference by introducing a way to decide if the two sample means are different enough to be confident in deciding that the population means differ. Pause the video and copy the essential question. What can you imply when two sample means are separated by at least 2 MADs? Example 1, texting. With texting becoming so popular, Linda wanted to determine if middle school students memorize real words more or less easily than fake words. For example, real words are food, car, study, swim, whereas fake words are steak, fanwa, conquer, tinspoon. She randomly selected 28 students from all middle school students in her district and gave half of them a list of 20 real words and the other half a list of 20 fake words. How do you think Linda might have randomly selected 28 students from all middle school students in her district? First, she will need to get a list of all middle school students in the district. Then she could either use a random number table, use a website to generate random numbers, and then use the numbers to select the student names, or put all the names in a bag and draw names. B. Why do you think Linda selected students for her study randomly? Explain. Random assignment is done to help ensure that groups are similar to each other. Question C. She gave the selected students 1 minute to memorize their list, after which they were to turn the list over, and after 2 minutes, write down all of the words they could remember. Afterward, they calculated the number of correct words they were able to write down. Do you think a penalty should be given for an incorrect word written down? Explain your reasoning. Pause the video and answer this question. It is an opinion question, so remember to explain your reasoning. Exercises 1 through 4. Suppose the data, which is the number of correct words recalled, she collected were as follows. For the students given the real word list, 8, 11, 12, etc. This is how many words the people recalled. And the students that were given the fake words list recalled 3 words, 5 words, 4 words, etc. On the same scale, draw dot plots for the two data sets. So notice that our lowest number is 1 and our greatest number is 14. So number our dot plot 1 through 14. Then go ahead and place your dots on the dot plot. Pause the video, complete the task, and then check your answers. Question 2. From looking at the dot plots, write a few sentences comparing the distribution of the numbers of correctly recalled words with the distribution of numbers correctly recalled faked words. In particular, comment on which type of word, if either, the students recall better, and explain. Here are some things to think about. Is there overlap in the data? If so, Is it a lot or is it a little? Is the data symmetrical? Is it skewed? And if so, which way? Where is it centered on each plot? Which type of word do you think students recall better? So let's take a look at the first question. Is there overlap? Overlap would be if the dots are in the same section for both the recall, the real words, and the fake words. For example, the overlap starts here at 4 words. Both groups recalled 4 words, and both groups recalled 5 words, 7 words, etc. Then the most that they both recalled was 11. Nobody recalled 12 fake words. So this is the section that overlaps. So is there overlap? And if so, is it a lot or is it a little? Well, there is overlap, and it is quite a bit. Is the data symmetrical? Now, when you're looking for is it symmetrical, you're looking for just the real data, one set of data at a time. So is it symmetrical? In other words, is the left side of the data the same as the right side of the data? And then for the fake, is the left side of the data the same as the right side of the data, or is it skewed? So there is a considerable amount of overlap, indicating that most people recalled between 4 and 11 words, for both fake and real words. Real words recalled is somewhat skewed to the left, indicating more real words were recalled by most people. So over here, notice that most of the data is on the right, meaning that the data was skewed left. Fake words were recalled in a fairly symmetric fashion, most recalling between 3 and 7 fake words. In other words, the data is pretty even spread to the left and to the right. The center of the data for real words is higher. I think more real words were recalled. When you're looking for the center of the data, remember to count the dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then the halfway point would be 1, 2, 3, 4, 5, 6. So right about here would be the center of the data for the real words, which was 9. And then the center for the fake words, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 7. 1, 2, 3, 4, 5, 6, 7, whereas 4 is the center of the data for the fake words. So the center is up here for real, and the center is down here for fake. Question 3. Linda made the following calculations for the 2 data sets. The real words recalled. The mean is 9.43. Remember, to calculate the mean, you would add all of these numbers and then divide by 14. To find the mean of the fake word list, you would add all of these numbers together and divide by 14. So we have a mean of 9.43 words for the real words and 5.36 for the fake words. How many MADs separate the 2 means? So the MADs are right over here, and recall how the MADs are calculated. If the mean is 9.43, then you would subtract 9.43 minus 8, 9.43 minus 11, 9.43 minus 12, 9.43 minus 8. And you take all of those differences and you add them together, and then you divide by 14, and that's your MAD score. So we have a MAD score for real and a MAD score for fake, and we want to know how many MADs separate the means. That is a division problem. That is the difference in the means divided by the larger of the 2 MADs. The difference in the means is a subtraction problem. 9.43 minus 5.36. The larger of the 2 MADs is 2.29. The difference is 4.07 divided by 2.29. And so our how many MADs separate the means is 1.78 MADs separate the means. In the last lesson, our work suggested that if the number of MADs that separate the two sample means is 2 or more, then it is reasonable to conclude that not only do the means differ in the samples, but the means differ in the populations as well. If the number of MADs is less than 2, then you can conclude that the difference in the sample means might just be sampling variability, and that there may be not a meaningful difference in the population means. Using these criteria, what can Linda conclude about the difference in population means based on the sample data that she collected? Be sure to express your conclusion in the context of this problem. Since the MAD is 1.78, and this is below the suggested 2 MADs, Linda would conclude that the average number of real words recalled might be the same as the average number of fake words recalled, because the number is less than 2. If the number is more than 2, then you would conclude that there's a meaningful difference between the population and that the number of real words recalled is more than the number of fake words recalled. This is example 2. Ken, an 8th grade student, was interested in doing a statistics study involving 6th grade and 11th grade students in his school district. He conducted a survey of 4 numerical variables and 2 categorical variables, grade level and gender. His Excel population database for the 265 6th graders, 175 11th graders in his district has the following description. In columns 1 through 5, there is data about the student's ID numbers, number of minutes texting, reaction time, the amount of time spent weekly on homework and sleep. Ken decides to base his study on a random sample of 20 6th graders and a random sample of 20 11th graders. Now, we reviewed how to conduct a random sample on question A, so you can review that if you would like to. Suppose that a random number generated these ID numbers for 20 6th graders. Then you go to the Excel document of data and you look up these ID numbers and find out how many hours of homework that student completed. For example, for the student whose ID number ends in 9, here is the ID number column. Follow it over to the homework column, and you'll see that the student completed 8.4 hours of homework. Pause the video and write down for each student how many hours of homework they completed. So here's what our data looks like for the 6th graders. There are their ID numbers in order, and here is their set of data. Now, I've given you a separate piece of paper with their data written down on them, and we'll use that paper to continue and make their dot plots. Question C. On the same scale, draw a dot plot for the 2 sample data sets. So up here is our data for our 6th grader, and then here is the line for the 6th grader and the line for the 11th graders. Our first set of data, 8.4 and 7.2. Here is 7.2, and here's the dot for that student, and then here is 8.4 hours. Then your next one would be 9.2. So you follow it over to 9.2, follow it up to the 6th grade line and put the dot. Pause the video and complete the dot plot for the 6th graders and the 11th graders. Put the 6th grade data on the first line and the 11th grade data on the second line. Resume the video when you are ready. This is what your dot plot should look like. Here are your dots for the 6th graders, and here are your dots for the 11th graders. Question D. From looking at the dot plots, list some observations comparing the number of hours per week that 6th graders spend on doing homework and the number of hours per week that 11th graders spend on doing homework. Think about these things. Is there overlap? If so, a lot or little. Is the data symmetrical? Skewed? If so, which way? Where is it centered on each plot? Hours spent on homework for each grade. There is some overlap. The 6th grade distribution may be slightly skewed to the left, indicating a higher amount of 6th graders work longer on their homework than other 6th graders. The 11th grade distribution is fairly symmetric. The mean number of homework hours for 6th graders is about 7 hours, right about here. And the mean hours for 11th grader is around 10 hours, more around here. And both of those are based on the center of data. And then again, when we're talking about overlap, remember that we were talking about numbers that are in common on both of the dot plots, such as here. That would be considered the overlap. Question E. Calculate the mean and MAD for each of the data sets. How many MADs separate the two sample means? Use the larger MAD to make this calculation if the sample MADs are not the same. You'll want to use the data set from B rather than from the dot plot. The numbers are easier to read here than they are from the dot plot. So the first thing that we want to do is to calculate the mean. So we're going to add up all of those numbers spent on homework and then divide by how many data points there are. And then we'll do the same thing for the 11th grade. And we'll do that for their data on homework, not their ID numbers. The mean time spent on the homework for 6th grade is 7.055. The mean time spent on homework for 11th grade is slightly higher, 10.32 hours per week. Then it says to calculate the MAD for each data set. To calculate the MAD, remember to find the distance each number is from the mean. We'll use our other paper to calculate the MAD. To calculate the MAD, remember to subtract 7.055 from each number. Here, 8.4 minus 7.055 is 1.345. 7.2 minus 7.055 is 0.145. 9.2 minus 7.055 is 2.145. Pause the video and continue finding the distance each number is from the mean. Once you've got that step complete, the next thing you want to do is add together all of those distances and then divide by how many numbers there are in the data set. The sum is 25.48. Divided by 20 numbers in the data set is 1.274. So our first answer, our first MAD, is 1.274. Then we'll repeat the process for the 11th grade. This time we'll be subtracting 10.32 from each number of hours. So 9.5 hours minus 10.32 is 0.82. 9.8 hours minus 10.32 is 0.52 hours. Pause the video and find the distance each number of hours is from the mean of 10.32. Then add those numbers together and divide by 20 to find the MAD. So we've completed that task and our answer is 1.052. We calculated the mean for the 6th grade and the 7th and the 11th grade. Then we calculated the MAD for each grade. Next, how many MADs separate the means? Remember that that is a division problem. It's the difference in means, so you're going to subtract the means. then you're going to divide by the larger mean, and the larger mean is 10.32. And this is going to give you how many mads separate the mean. We subtract, and we get 3.265. The larger of the two means, 1.274. Do the division, and the answer is 2.56. So the question was, how many mads separate the means? And the answer is 2.56 mads separate the means. Ken recalled Linda suggesting that if the number of mads is greater than or equal to 2, then it would be reasonable to think that the population of all 6th grade students in the district and the population of all 11th grade students in his district have different means. What should Ken conclude based on his homework study? Since 2.56 is greater than 2, it is reasonable to conclude that the average 11th graders spend more time doing their homework per week than do 6th graders. Just a reminder and a study tip. If the number of mads that separate the two means was less than 2, you can assume there is not a meaningful difference and that the 6th and 11th graders spend an average of the same amount of time on homework. In this lesson, you have learned to determine if the mean value of some numerical variable differs for two populations. Take random samples from each population. It is very important that the samples be random samples. If the number of mads that separate the two sample means is 2 or more, then it is reasonable to think that the populations have different means. Otherwise, the population means are considered to be the same.